Okay, in this video I'm going to talk about valid arguments, and I'm not going to use quantifiers in this video. I'll do so in later. So in determining whether a logical argument is valid or not, there are some standard types, and if you recognize that the argument is of the standard type, you can just name the type and say whether it is valid or invalid. I'm going to talk about 6 types: law of detachment, law of contraposition, fallacy of the inverse, fallacy of the converse, disjunctive syllogism, law of syllogism. The ones called laws will all be valid. Also, the disjunctive syllogism is in addition valid. The fallacies are invalid. Now, in truth, all of these will be syllogisms. Syllogism is a fancy word meaning you have 2 things that are the premise for your argument, and you'll have one conclusion. That's all a syllogism is. We'll go through each of these 6, and then I'll talk about what happens if you have an argument that is not one of these. But first, let me talk about what valid means. Valid is not the same thing as saying that the conclusion is true. What it really says is, assuming that the premises are true, then the conclusion must logically follow from the premises. Now, you can have an argument that is invalid. There's no logic to it, but you have a true conclusion. That's possible. You can have an argument that is valid, and the premises are false, and the conclusion is false. Because remember that in the definition, if the premises are true, then the conclusion logically follows. But if the conclusions are false, if the premises are false, you may still have a valid argument, and you may have an untrue or false conclusion. Okay, so the first of our types was law of detachment. So we'll have 2 sentences that are premise. The first is a conditional, if P then Q. And the second premise is the if portion of the conditional. And the conclusion is the then part of the conditional. So I've put up 2 examples here just to emphasize that we can have valid arguments that come to different conclusions. Completely different. If you look at these 2 at the bottom, one says we build the wall, one of them says we don't. At the time that I made this video, that was a big deal in America. But, okay. And both of them are law of detachment. We've got a conditional here, and then the second premise is the if part of the conditional. The conclusion is the then part. So it fits this pattern. It is a valid argument. Law of detachment always leads to a valid argument. Second thing is the same setup. A conditional. The second premise is the conclusion. Is the if part, and the conclusion is the then part. So they're both valid arguments. They're both law of detachment. Now, what's going on in America right now? Some people believe that this premise is true, and some people believe that premise is true. And so that's where the big disagreement is, not really in whether they're valid arguments or not, but are the premises true or not? Okay, moving on to less controversial material. The second standard type is law of contraposition. Notice that's very close to the contrapositive. Okay, that's a word we had before. So, first premise, conditional. Now remember, this conditional is the same as the conditional if not Q, then not P. That's called the contrapositive. So this premise, the second premise, is really the if part of the contrapositive. and the conclusion is the then part of the contrapositive. So you can think of it this way. If you replace this premise with its contrapositive, then you really have a law of detachment going on here. But these two together, saying this is the same as its contrapositive, and then doing a law of detachment, together that's called the law of contraposition. So here's an example. I have a conditional, and this is true. One of the conditions for running for president of the United States is you have to be a natural-born citizen. Now, notice the conditional does not go the other way. Just because you're just because you're a natural-born U.S. citizen does not mean you're running for president. So the conditional moves in one direction only. Okay. So we've got this conditional. The second premise is the negation of the then part, and the conclusion is the negation of the if part. This is law of contraposition. This argument is valid. Okay, third type is confusing a conditional statement with its inverse. So let's see here. This setup, and remember this is invalid, this setup is if P then Q, and not P, and the conclusion is not Q. So somebody confused this conditional with its inverse. Its inverse would be if not P, then not Q. Well, if I did have that, if I had if not P, then not Q, then this would be the if portion of the inverse. This would be the conclusion of the inverse. So if I had the inverse statement, I'd have a law of detachment. But unfortunately, this conditional and its inverse are two different statements. They're not the same. And so you lead to things that are an invalid argument. And here's a good example telling, if you are running for president, you are a natural-born U.S. citizen. Okay, we already talked about that. Okay, so we got somebody who's not running for president. Does that mean that person is not a natural-born U.S. citizen? I think not. I mean, right now there's a lot of people running for president at the time I'm making this video. But really, most of the people who are not running for president are U.S. citizens, or those living in the United States are U.S. citizens. So, okay, there's plenty of people that are natural-born U.S. citizens not running for president. So trying to say you're not running for president means you're not, that doesn't work. This is an invalid argument. And I knew it right away, not because I knew facts about the Constitution, but because of the setup. It was a setup of the fallacy of the inverse. Now, I will mention this, as I talked about in an earlier video. Some people confuse a conditional with its biconditional. And some people, when they mean to say the biconditional, they say if then. So, suppose this were P if and only if Q. Suppose this first one were a biconditional, and the second premise stays unchanged, and the conclusion stays unchanged. That is actually a valid argument. It's not, doesn't have a special name to it, but it is a valid argument. So, yeah, if a person really meant a biconditional here, this would be valid. Okay. Fallacy of the converse. It's an invalid argument for about the same reason. People confused conditional with its converse. Now, the converse would be if Q, then P. So this is the if portion of the converse. This is the then portion of the converse. But unfortunately, I can't do that. I can't replace this statement with its converse and have the same argument. So this is wrong. And okay, here we go. Same thing again, same if-then statement. And now my second premise is the then part. And my conclusion is the is the if part. So, right, every natural-born U.S. citizen is running for president. I don't think so. I don't think that's the case. This is an invalid argument because of the way it's set up. Okay, disjunctive syllogism really is, process of elimination is what it is. But disjunction, remember, is an or statement. Syllogism, as I said, is two premises and a conclusion. So think of some people talking at a party. One says, and I put in parentheses, this is not part of the argument. But one person says, I saw him at either Mike's or David's. Can't remember which. The other person says, no, he wasn't at Mike's. Nope. Okay, so I conclude I saw him at David's. Okay, right, process of elimination. Yeah, that's valid. But in logic, we have a fancy name for it. Law of syllogism. Remember, these are arrows. So if I have an arrow going from P to Q, and I have an arrow going from Q to R, then I can draw an arrow from P to R. Or we have a causation. P causes R, maybe. You can think of it that way. Okay. So I've got in my example, if you're going to replace your old car, you're going to need to get a raise. And in order to get a raise, you're going to have to impress your boss. So in conclusion, if you want to replace your old car, you're going to need to do something to impress your boss first. Okay. Valid argument, law of syllogism. So what if it's not one of these 6 types? You're going to draw a truth table. You're going to have the premises, you're going to have the conclusion, and you're going to look for rows where all the premises are true and the conclusion is false. If you can find any such row, then the argument is invalid. And if that never occurs, then the argument is valid. Okay, so here's an example. If I get a B or higher in Calculus 1, I'm either going to major in chemistry or physics. So this is a guy knows, or gal, knows she wants to go into the STEM field, but Calculus 1 is a tough math course, and decides for herself, if I can get a good grade in Calculus 1, I'm going to go into the STEM field. And then later, takes a physics class, decides I'm not going to do that. So it says, okay, I'm going to major in chemistry. Now, is this valid or not? So I've got a truth table here. And notice I've got separated one premise, another premise, a conclusion, excuse me, that thing bumped out of place there. And then I looked at the first premise and I circled its final thing. I looked at the second premise and I looked at the conclusion. Well, that didn't really have anything to it. Well, I should mention, these are non-standard letters, right? Usually we have P, Q, R. So you just put them in alphabetical order. So I put the B and then the C and the P. And we have the standard, 4 trues, 4 falses, the standard order. Okay, now that I've filled out the truth table for each statement, and here's the final columns in each, and then start looking, is there a time when, as I mentioned in the previous, is there a time when all the premises are true and the conclusion is false? And yes, in this very last row, the first premise came out true, the second premise came out true, but the conclusion came out false. So the conclusion is this is an invalid argument. All right, thank you. We'll do Euler diagrams for quantifiers next.